Good morning, students. Today I am here with class 12th, chapter number 5, lecture number 3. Let us start by discussing some of the questions of our exercise 5.1 itself. Here comes question number 24. In question 24, we have been given a function f of x whose conditions are given. When x is equal to 0, it will be 0. When x not equal to 0, the function value is x square into sine of 1 by x. We have to determine whether this function f is a continuous function or not. Let us check. So how many cases will there be? When x is less than 0, when x is greater than 0, and when x is equal to 0. So when x less than equal to 0, okay, let me write it. X greater than 0 and x equals 0. So when x is less than 0, you see x equal to 0, value is 0 of the function, but not 0. That means whenever it is greater than or less than 0, the function will remain as x square sine of 1 by x in both the cases. Clear? Now you know x square being a polynomial function is continuous, and sine of 1 by x will definitely give you a definite value. Why? Because we know sine theta lies between -1 and 1. So sine of 1 by x is also some angle. Its value will lie between -1 and 1. So it is a definite value. So it will be a continuous function. Product of two continuous function is a continuous function. Let us speak about this case when x is equal to 0. What is f equal to 0? F of 0 is 0. So we will solve LHL and RHL for these two. Let us solve LHL and RHL. LHL, RHL. So we know f of 0 was 0. So we will just put for 0 minus and 0 plus. We know when the function is not equal to 0, as you can see carefully, when it is not equal to 0, that means for greater than and less than, we have to take the function as x square sine of 1 by x. Let's take that. X square sine of 1 by x. Change it to limit h tending to 0. So you will get, see, 0 minus h square is h square only, and the sine of 1 upon 0 minus h. So you get h square and minus, because sine of -1 upon h is sine 1 upon minus sine 1 upon h. Limit h tending to 0. Now you know, putting h as equal to 0, this will be 0 into, you know, this is going to give us a definite value, because we know any angle of sine will give us a value between -1 and 1. So let that value be k. So the answer will be 0. Similarly, when we solve for this, here we will get as h square into sine of 1 upon h. When we put limit as h tending to 0. Correct. Now solving this, we will get h square, that means 0 into a value, and it will be 0. Because sine theta lies between -1 to 1. So sine of 1 by h is also some angle which will lie between -1 and 1. Clear? So this is what we need to do in question number 24. Let us go to the next question, which is question number 26. In question number 26, they are asking to find the value of k when this function is continuous at the indicated point. Indicated point is pi by 2. So if it is continuous, that means we know f of pi by 2, LHL and RHL. These three things are equal. Let us find and equate them. So f of pi by 2, you know what is it given? When x is equal to pi by 2, see, it is 3. Let us solve the LHL. In LHL, what do we have? We have limit x tending to pi by 2 minus. So for pi by 2 minus, we are going to take this case, because for equal to pi by 2 we have 3. But when it is not equal to pi by 2, that means less than pi by 2 or greater than pi by 2, the function value that we have is k cos x upon pi minus 2x. So changing it to limit h tending to 0, we have k cos of pi by 2 minus h upon pi minus 2 into pi by 2 minus h. So now I'm writing here just to see, we will get limit h tending to 0, k, okay, cos 90 minus theta, you know what is it? Sin theta, that means sin h, upon pi minus, multiply 2 inside the bracket, we get minus pi plus 2h. Okay, so pi and pi getting cancelled, so we have limit h tending to 0, k upon 2 into sin h by h. Taking the constant out and applying the limit to this expression sin h by h, we see this is equal to 1, right? So the answer will be k by 2. This is what? LHL. Clear? Now because it is continuous, so definitely RHL is also going to be k by 2. Correct? Let us just solve that and verify. RHL. In RHL, you will have limit x tending to pi by 2 plus the function is k cos x upon pi minus 2x. Changing it to limit h tending to 0, k cos of pi by 2 plus h divided by pi minus 2 into pi by 2 plus h. Solving this, what do we get is, see here, we will get limit h tending to 0, k into, now you see k into we have cos of pi by 2 plus theta. So as it is 90, we will definitely change it to sine. But as you can see, pi by 2 plus theta is second quadrant where cos is negative. So instead of sin h, we will get minus sin h divided by pi minus, we will have pi minus 2 and 2 will get cancelled. So we will have pi minus 2h. Pi getting cancelled. We have limit h tending to 0 minus k sin h upon minus 2 upon h. So we again have k by 2 limit h tending to 0 sin h by h, which you know as applied in the LHL also is equal to 1. So we are getting what? K by 2. Okay, and what was f of pi by 2? Which is 3. So now because it is continuous, we will equate it, right? As you can see, I have written here, we are getting the values. Now let us put f of 3 as equal to LHL or RHL, which are same. So f of 3 is 3, sorry, f of pi by 2 it is. F of pi by 2 is 3 and LHL we are getting as k by 2 and RHL also. Solving this, we get k as equal to 6. So if this function is continuous at x equals pi by 2, that means the value of k is 6 here. So let us go to the next question now. Here comes question number 28, which is almost similar to the previous question that we have discussed. In question number 28, they are again asking you to find the value of k when the function is continuous at pi. As we have done in the previous question, same you are going to do here. Just to see, f of pi will be cos pi. Or no, it will be, see, equal to sign is here. So for equal to pi, we are going to take the function as kx plus 1, which is k pi plus 1. Now let us find the LHL just to see when it is less than pi. So limit x tending to pi minus the function will be kx plus 1. Changing it to h tending to 0, we get k into pi minus h plus 1. Putting h as equal to 0, we get k pi plus 1. Let us solve RHL. RHL will be limit x tending to pi plus. For pi plus, the function is cos x. So limit h tending to 0 cos of pi plus h. Putting h is equal to 0, we get it as cos pi, and we know cos pi is equal to -1. Now we know that the function is continuous at this point. We can equate our LHL and RHL. Let us do that on a separate sheet. So equating LHL and RHL, this we are doing according to the question. So we are getting what? K pi plus 1 in LHL, and in RHL we got -1. You can see that. RHL we are getting -1, LHL K pi plus 1. So solving it, K pi is equal to -1 -1. K pi is equal to -2 and k is equal to -2 upon pi. So this is the value for the constant k if this function which is given to us in question number 28 is continuous at x equals pi. So this is about question number 28. Let us go to the next question now. So here comes question number 30. In this question number 30, we have to find the values of a and b such that the function is continuous function. Now when it is continuous, we know, see at 2 we can check, we have less than 2 and greater than 2. At 10 we can check, okay, so that we have two equations. How this is possible? Just to see here. What is f of 2? F of 2 means 5, right? As you can see, equal to sign here. LHL at 2 I am checking first, okay. What will be LHL? Limit x tending to 2 minus. For less than 2 we have the function is 5 only. So the answer is 5. Let us find RHL. Limit x tending to 2 plus, and the value of the function is ax plus b. Now when we put it as limit h tending to 0, a into 2 plus h plus b, so we get the answer as 2a plus b. So as it is continuous given, so we can write that LHL will be equal to RHL. So the first equation that we are getting is 2a plus b equals 5. Now let us check at x equals 10. So at x equal to 10, we have f of 10 as 21, as we can see here. Okay, let us find our LHL. Limit x tending to 10 minus. For 10 minus, we have the function as ax plus b. Right? For less than 10, see ax plus b. So limit h tending to 0. Instead of x, we will write 10 minus h plus b. So we get it as 10a plus b. Clear? And for RHL, you can directly see for RHL, for greater than 10, we will have 21 only. So now because it is continuous, we can again put our LHL and RHL equal. So this was our equation 1. The second equation that we will get is, just to see, we have 10a plus b equals 21. So this is our equation number 2. Now we will solve both the equations to get the values of a and b. I think everybody can solve these two equations and get the values of a and b. That's it. You need to do the questions. So complete it in your notebooks. Let us discuss the next question, which is question number 31, in which they are saying, show that the function defined by f of x cos of x square is a continuous function. So in this question, function given is cos of x square. Let me tell you one thing. If f is a function, okay, and g is also a function, both are continuous, so their composition g of f of g is always continuous. So let us apply this to our question. F of x is given as cos of x square. So whatever is given as first, we will consider that as a g of x, which will be cos of x, and another one which is coming after cos is x square. So let us see whether this is a composition of g of h or not. So g of h of x will be solved as g of h of x. What is h of x? x square. So you see, when it is g of x, it is cos x. So instead of this x, what we are placing now? Cos of x square. So instead of x, what will come? Cos of x square. So yes, it is a composition of two functions, one g and one is h. So we can directly now write cos x is a continuous function at all the real values. X square being a polynomial function is continuous everywhere. Hence, composition of these two functions will always be a continuous function. That's what you need to do in this. So one more type of problem of the same kind we're going to discuss here. So let me bring that question here now. This is the next question. Here you see we have been given mode function. So first function we will consider as mode of x, and second function as we see it is cos. So I'll consider that as cos. Now find out g of x and see whether this function is formed or not. G of h of x. H of x means cos x. Right, so you see when inside g it was x, it is coming inside the modulus. Now it is cos x, so cos x will come inside the modulus. So you say that mod x is a continuous function, cos x is a continuous function. Clear? Everywhere. So the composition of these two continuous function will be a continuous function only. Clear? This is about this composition of functions. Now we will do the last question of the exercise, which is very important for you all to understand. First of all, we will break the function. Now see, the critical point from here is x equals 0. From here it is x equals minus 1. Okay, so we will check at which points? We will check at x less than minus 1. Okay, x equals minus 1, then between minus 1 and 0, fine, and we will again then check from 0. Clear? X equals 0 and x greater than 0. These are the cases. Now let us combine them and form the functions. Just to see x less than minus 1. So let us take this. Okay, so x less than minus 1, how this function is going to behave? I will write here x less than minus 1. Just to see, x less than minus 1, both the modulus functions are going to behave as negative. So this one will become minus x minus of minus x plus 1. Minus x minus would be plus x plus 1. So we are getting the answer as 1 itself. So when x is less than minus 1, the function value is 1. And also equal to minus 1, we will get as 1 only. Now let us check between minus 1 and 0. Correct. Now between minus 1 and 0, we get the answer as how? Between minus 1 and 0, what about modulus of x? This will remain negative. What about mod of x plus 1? It will be positive. So minus x minus 1. We get minus of 2x minus 1. Clear? Now let us find the last one when x is greater than 0. So when x is greater than 0, both the modulus function will behave as positive. So x minus 1. So when we cancel it, we get minus 1. So now this is the function, or we have converted our question into a much simpler question that we have been doing in the exercise. Now we just have to solve it out. Yes, let us solve it. So now check for x less than minus 1. So I'll just take another sheet and we'll write all the things. So what are the function value that we are getting? Let me write again here. So we got like this: when it is less than minus 1, the answer is, let us check, what did we get? We get 1. And between minus 1 to 0, we get minus 2x minus 1. And last one, for x greater than 0, we are getting minus 1. Now for x less than minus 1, the very first case, x less than minus 1, what do we get? 1 is the function. So the value of the function is 1 here. Being a continuous function, constant function, it is continuous. In the second case, let us check at x equal to -1. So at x equal to -1, c equal to sign is here. So f of -1 is 1 only. Let us check LHL, limit x tending to -1 minus. So less than -1, we have 1 only. So it is 1 only. Clear? So these two are equal. Let us see the RHL for case 2. You will write limit x tending to -1 plus. So greater than -1, the function is -2x minus 1. Right? So let us solve it. Limit h tending to 0 -2. Instead of x, we will write -1 plus h minus 1. So putting h is equal to 0, -2 and -1 is 2. 2 minus 1 is 1. We can see LHL, RHL and value of the function at point -1 is equal. Clear? Now you see the third case here. So it is continuous when x is less than -1 at x equals -1. Between -1 and 0, the function value is -2x minus 1. So being a polynomial function, it will be continuous. Also, the fourth case you will check for between at x equals 0. So as I have checked for -1, you will check for x equal to 0. And in case 5, just to see for greater than 0, we have it as a constant value, so it will be continuous. Now your work only left is to check for 0, as I have checked for -1. This is all about the exercise 5.1. So now after this, the homework questions that you will do are, so the homework questions are from exercise 5.1, question number 25, 27, 29 and 33. Only 4 questions. So you will also get a solution of this in the next video. So that's all for today. Thank you so much.